Hello everyone, this is Mr. Molo for lesson 7-4, solving polynomial equations in factored form. So this first part is something we're probably going to need to know for next lesson, but we're going to talk about it here now. So factored form is what we're used to seeing with the two parentheses. Standard form is what we do after we do our foiling there. And then non-standard form is pretty much just the same thing as standard form, except there's something on the, or there's a number on the other side of the equal signs that's not a zero. So like if we look here, like lowercase a ends up getting paired with uppercase C, those end up being the same thing. So once I distribute those, I'm pretty much just looking at -1 times -3 is +3, and that's the only one with a +3. And then if I kind of look, then that one looks a lot like this one, except they just subtracted 3 from each side. So then our series would be the lowercase a is the same as the uppercase C, and the uppercase C is the same as the number 5. So just kind of the three forms that we should know to put these in. Okay, and then if I start with B over here, B, if I multiply -2 and -3, I get +6. The only one with the +6 there is the capital D. And then again, they rearranged this one a little bit, and they subtracted 6 on each side, and it looks like that one, number 1. Okay, and then lowercase c, -2 times +1 is -2. Oh, there's 2 with a -2 here though, except -2 plus 1 is -1x. So that one's going to get matched with capital A. And then if we look at this one, it looks like they just added 2 to both sides. So 2 plus 0 is 0. So that gets matched with 3. And then D, this one, same thing, is going to be a -2. So now this one must get matched with B. And then if I look here, this one, it looks like they pulled out the x first, which we'll talk about here today. So this one's actually going to match with 4. And then the only combination left is E to E to 2. So multiplying +1 by -3 is -3. And then it looks like they kind of just took the square root of that one there. Or, I'm sorry, they squared that one there. Okay, so kind of some stuff that you need to know for today is pretty much just that one right there. Otherwise, the factored form and the standard form we've been used to. So on today's stuff, I want you to solve the equation. Okay, so you'll notice most of these are set up to equal 0. So what could x possibly be to make this problem equal 0? Okay, and the way you're going to do it is you're pretty much going to set every x equal to 0 and then kind of just solve. So this x, I'll do this one in purple, I'm going to set it equal to 0. So x equals 0, and that's done already. X could be 0. If x is 0, this whole problem equals 0. So if x is 0, then I plug in a 0 there, that is a true statement. 0 plus 5 is 5. 5 times 0 is 0. So x could be 0. That is one possible solution for this. Then, like I said, we're going to take the other part of the problem. So in this case, x plus 5. And then we're also going to set that equal to 0. So x plus 5 equals 0. I'm going to put in a negative. So I'm going to subtract 5 for both sides. So x could also be -5. I'll double check my work here in a second. So now if I plug in a -5 for every x in that problem, -5 plus 5 is 0. So now there's a 0 in the parentheses. -5 times 0 is 0. So there's two ways that I get this problem to equal 0. One is if x is 0, and one if x is -5. So you're pretty much just going to set up both variables equal to 0 and kind of solve from there using some algebra. All right, let's look at number 2. 2, same thing. I have a, and then parentheses a minus 12 equals 0. So again, I'm going to set up a equals 0, and that first answer is usually pretty simple. A could be 0. Again, I'll double check my work here. If I put in a 0 for the first a 0 for the second a, does that equal 0? So 0 minus 12 is -12. And then 0 times -12 is 0. So yep, 0 does equal 0 in this case. Okay, and then for the next one, I'm going to take the a minus 12 that's in the parentheses and set that a equal to 0. I'm going to add 12 to both sides. So when I solve it, I get a equals 12. My two answers are 12 and 0, and I'm going to double check this stuff in green, plug in 12 for each a, and see if I in fact do get 0. So 12's across the board. 12 minus 12 is 0. So now in my parentheses I have 0, and 12 times 0 is 0. So yes, that does work. 0 does equal 0, so my two answers are 0 and 12. Okay. 3, kind of the same thing, except now there's a 5p in front of it, but that doesn't really change my answer. 5p equals 0. I divide both sides by 5. 0 divided by 5 is 5. So p could be 0. Same thing, you can double check your work. And then I set my other parentheses equal to 0. So p minus 2 equals 0. Add 2 to each side. My other answer could be 2. So p could either be 0 or p could be 2, and that ends up equaling 0 for this problem. Okay, those I think are a little more complicated because it's harder to set up. I really like problems like 5, 6, and 7 because they already kind of have it set up for you. You're just literally going to take both equations or both parentheses and set them equal to 0. So c minus 2 equals 0, and c plus 1 equals 0. And most of you are saying, Mr. Mullen, we did this like the second day of school. You're right, we did. So add 2 to both sides. So c could be 2, and that would make my equation equal 0. Subtract 1 from both sides. Or c could be negative 1, and that could make my equation equal 0. So then my two answers for this one are 2 and negative 1. 5 gets a little more complicated just because it's 2 steps, but again, probably something we did in chapter 1. So 2b minus 6 equals 0. And then 3b plus 18 equals 0. So I'm going to add 6 to both sides. So I'm left with 2b equals 6. Divide by 2, divide by 2. So b could be 3, and that would make my equation equal 0. Or if I do the blue problem down here, the second set of parentheses, I get 3b equals negative 18. Divide by 3, divide by 3. And b could also equal negative 6. And that would make both my equations equal 0. And then again, if you go back and plug it in, if I plug in like 3 for b here, 2 times 3 is 6. 6 minus 6 is 0. So no matter what this parenthesis is here, this first parenthesis is already 0. So anything times 0 is going to be 0. And then same thing with this blue problem here. 3 times negative 6 is negative 18. Negative 18 plus 18 is 0. So it doesn't matter what b is in this first parenthesis because the second one is 0. So anything times 0 is 0. Okay. 7 kind of looks a little trickier, even though it's kind of actually easier. So that just means x minus 3 squared. So that means x minus 3 and x minus 3. So set both of them to 0, and you'll quickly realize that it's the same answer. So x minus 3 equals 0, and x minus 3 equals 0. So add 3 to both sides. So x equals 3 for the first one. So x equals 3 for the second one. So really, you just have one answer. You don't have to put in 3 twice. X is 3. Okay, so most of these are going to have 2 answers. This one you'll see only has 1 because there's only one x in there. But then when you get down here, these, with the exception of number 10, like number 11 and 12, are going to have 3 answers because there's 3 variables. I have a g, I have a 3g, and I have a 3g. Same thing with 12. I have a negative m, 2/3 m, 3m. So you're pretty much just going to do the same thing. Set each part equal to 0. So g equals 0. 6 minus 3g equals 0. And then 6 plus 3g equals 0. So just a little bit more work just because there's 3 different problems now, so you're going to get 3 answers. First one's already done for us, g equals 0. Don't have to do anything there. Second one, I'm going to subtract 6 from each side. So I get negative 3g equals negative 6. Divide by negative 3, divide by negative 3. So g equals 2. That's one of my answers. And then subtract 6 in the last one. So I get 3g equals negative 6. Divide by 3, divide by 3. So g equals negative 2. So g equals 0, g equals positive 2, and g equals negative 2 are all answers. And again, if you go back and plug them in to kind of double check, if g is 0 here on the outside, well then, yep, anything you multiply it by is going to end up making the problem equal 0. If g is positive 2, 3 times positive 2 is 6. Well, 6 minus 6 is 0, so now the middle parenthesis is 0. Anything times the middle parenthesis, if it's 0, is going to end up equaling 0. And then here, negative 2, 3 times negative 2 is negative 6. 6 plus negative 6 is 0. So now the last parentheses equals 0. So anything you multiply in that last parenthesis is going to end up being 0 anyway. Okay. Here, it wants us to factor. Remember, factor. You are pulling out the most thing that they both have in common. So we're looking at not only number, but also variable. So greatest common factor between, let's do numbers first, 3 and 6. So my greatest common factor between 3 and 6 is 3. 3 can go into 6, 3 can go into 3. So that's my greatest common factor. Now my x's. This one has 2 x's, this one has 1 x. So they both have 1 x in common. So my greatest common factor is 3x. And then we still have to make the parentheses there. So 3x times what is going to give me 6x squared? Well, 3 times 2 is going to give me 6. And then x times x is going to give me x squared. And then the second one's already kind of done for us. So I just need a 1 there. So I'm just kind of simplifying the formula there. So that's going to be my final answer. All right, same thing on 14. So greatest common factor between 4 and 20. So 4 can go into 4, 4 can go into 20, so that's my greatest common factor. And then I have 4 y's here, and I have 3 y's here, so the most y's they have in common is 3. They both have 3 y's in common. Okay, and then in your parentheses, I need to go from 4y to the third to 4y to the fourth. Well, I already have a 4 and a 4, so I'm good there. I don't need any numbers, but I still need one more y. So from y to the third to y to the fourth, I need another y. And then to get to negative 20 y to the third, well, my y to the third and y to the third, I'm good there. So I don't need any more y's, but I do need to get to negative 20, and I'm at 4. So 4 times negative 5 gives us negative 20. Okay, greatest common factor between 18 and 6 is 6. 6 can go into 18, 6 can go into 6. And then they have 1 u in common. That one has 4 u's, that one has 1 u. So we're good there. And then to go from 6 to 18, I need to multiply by 3. To go from 1 u to u to the fourth, I need 3 more u's. And kind of the same thing there. I have a 6u, I need to get to negative 6u. So I need to multiply by negative 1. Okay. Here, greatest common factor between 7 and 2, well, there isn't one. 2 can't go into 7. 7's too big, it can't go into 2. So we're not going to have a number out there. I guess you can put a 1 out there if you want. But we do have some z's in common. This one has 7 z's, this one has 6 z's. So they both have 6 z's in common. So to go from 1 z to the 6th, I need to multiply it by 7z. And to go from 1 z to the 6th to get from 2z to the 6th, I need to multiply by a 2. So just pulling out, remember, the greatest number they have in common, and then the greatest amount of variables they have in common. And then here, 19 through 24 is pretty much the two of them combined. So you're going to factor it first and then solve. So my greatest common factor between 6k squared and k, so they don't have any numbers in common, but they both have a k that I can pull out. So to go from k to 6k squared, I need another 6k. To go from k to k, I just need a 1. And now they want you to actually solve just like we did on the first ones. So k equals 0. So there's one answer. And then 6k plus 1 equals 0. So subtract 1, subtract 1. So 6k equals negative 1. Divide by 6, divide by 6. So then my other answer is negative 1/6. Okay, let's look at one more here. So my greatest common factor between 35 and 49 is 7. 7 can go into 35, 7 can go into 49. This one has one n, this one has two n, so they have one n in common. Now to go from 7n to 35n, I still need another 5. And then to go from 7n to negative 49n squared, I need a negative 7n. Okay, same thing, set both parts equal to 0, so 7n equals 0. Divide by 7, divide by 7, so n equals 0. And then the other equation, 5 minus 7n equals 0. So subtract 5, subtract 5. So you have negative 7n equals negative 5. Divide by negative 7, divide by negative 7. So n could also be 5/7. And these other ones, they don't have an equal 0 there. So the only thing you have to do is just add whatever it is over there. So add 72x to each side. So then your new equation really just looks like 6x squared plus 72x equals 0. And then kind of the same thing. Subtract 11s squared, and then subtract 21p so that it equals 0.